Hello everyone. Today I'm going to introduce our final assignment. We are group 4. YouTube link will be provided after completion of this video recording. Our assignment is about top 100 movies we collected from imdb.com. The process is web scraping, cleaning the data, and sentiment analysis, image recognition, and visualization. I'm Monika Alapati, acting as a business analyst, Emeka Thompson, programmer, Attila Acar, database administrator, Nikita, acting as a data analyst. Tools we used are Jupyter Notebook, Weather Sentiment, Beautiful Soup, MongoDB, Python, Custom Vision, and Power BI for visualization. So web scraping part will be explained by Emeka Thompson.
Thank you, Monika, and welcome to the web scraping section of this project. My name is Emeka Thompson, and I'm the programmer. To scrape data from IMDb, the first thing to do is to import our useful libraries. So we import request, the Beautiful Soup pandas, CSV, feedparser, and stopwords. Next, we create columns for our data frame. Here, we've created 10 columns. The next part is the actual web scraping. We start by defining browser headings and then setting our page logic with NumPy. In this assignment, we'll be using 2 pages to get 100 movies for reviews. We put in our URL, we pass our URL with requests, we pass our requests in Beautiful Soup as soup, and then we create an object, movie div, and then we begin scraping the web contents. When we have scraped the main contents and we have gotten the links for our review pages, we begin to fetch the review data and save our content in the review column. Next, we create a pandas data frame and assign our columns to the data frame. After we've collected all our data, the next step is to clean the data frame. We print out the movie head to ensure that our code worked, and finally, we save our data as a CSV file. And now, I will demonstrate how our code works. We start with importing relevant libraries, and then we assign columns to the pandas data frame, and then we set our headers to match our browser type. Here, we're setting our page using NumPy to ensure we have 2 pages so we could get 100 movies. In this section, we assign our URL link and iterate our script code over these pages. Here's our link, and here's our page number as string. We use Beautiful Soup for our scraping. Here, we iterate over every section and then we get data and then store them into the columns that we've created earlier. Next, we use the link we've created to get our review links. We create another request response and we pass in our review links. We create an object called content and use the findAll method in Beautiful Soup to extract the reviews. We save these reviews in a list and then we append to a review column. We only append the first 5 reviews from every movie link. Next, we create a pandas data frame called movie. We assign our columns to each column in the data frame. Here, we print the data frame to the console. And we see we have our unique tags, our movies, our year in brackets, our runtime, our IMDb rating, genres, and votes. And below here we have our URL for the data, our image links, and finally our reviews as a list. The next step is to clean our data frame. We start by cleaning the year column by removing brackets and converting the text to numbers. Here we change min to minutes, and then we convert our votes from text to numbers and we remove commas. Upon printing the movie head, we'll see the brackets are no longer there, or the votes will no longer have commas. Next, we convert our reviews column from list to string. Then we delete punctuation from the reviews column. We delete all stop words. We ensure that each row has a minimum of just 3 words. And finally, we convert to lowercase. We print the data head to console, and we can see, compared to the former data frame, we have no stop words. They're all in small letters, and there are no punctuations. And finally, we save our data frame to CSV. And now, Attila will take it from here. Thank you.
Thank you, Emeka, and this is Atilla. I am the programmer in this project. Today, I'll go through the sentiment analysis. As Emeka mentioned before, now we have movies data frame. Let's check the data one more time. So as you can see in our movies data frame, we have the ID and unique movie tag, which is title ID, and we have the movie name, we have year information, runtime information, IMDb rating score. We have the genre, which could be comedy, drama, action, adventure, etc. We have the votes information, and we have the movie link here in the data frame. We have also image links information and the review information for each movie. So basically we have 11 fields in our movies data frame. So the next, I imported the pandas to convert list objects to data frame objects. And I also import sentiment intensity analyzer from Weather Sentiment to calculate polarity scores. So what we do in here is that we set sentiment intensity analyzer as analyzer. Then we create an empty list, and for each review in movies data frame, we calculate the polarity scores for each row, set it to PS, and then we append. In other words, we insert all the PS values into our list. Now, as I mentioned before, I gotta use pandas data frame function to convert the list to a data frame. What we call as DF sentiments. So let's run this. Now we have all the polarity scores for each row. Negative values, neutral values, positive values, and the compound values. So now, so far we have the movies data frame, and also we have the DF sentiments data frame that stores all the polarity score information. So time to merge, in other words, concat those two data frames into one data frame called DF join. To do this, I used pandas concatenation feature. And as you can see, we have the data frame here, movies, and the DF sentiments. When we run this code, basically we're going to join those two data frames. Meanwhile, we reset the index. So let's run this. Now, as you can see, we have all movies data frame information here, and plus we have the negative, neutral, positive, and compound scores at the end. After that, we also added two more fields in DF join for Power BI purposes. The one called sentiment, and the second one will be words. How we populate those two fields is the first one, the sentiment field, is populated by compand field, and if the polarity score is greater than or equal to 0.01, we set it as positive. If the polarity score is less than or equal to minus 0.01, we set it as negative, and the rest we set it as neutral. And the words field is populated by review field, and we create this for, as I said, Power BI purposes. Let's run them and see the data. So now we have all the data and also sentiment and words information, which is in array format. And now time to connect the MongoDB. To do that, we import a Mongo client from pmongo. And I set it all the credentials to connect the MongoDB. Let's run this and check our MongoDB. So we have the movies here, we have no database, we have no collection. Let's refresh one more time to see it. As you can see, we have nothing in here now, and time to insert all the data into our database. So to do that, we created a test database, and under this test we set it as DB, and under this DB we create a sentiment data collection. Then we need to convert our data into dictionary format because MongoDB accepts data in JSON format. So basically in DF join data frame, meanwhile we reset the index, and our DF join data frame, for each record we convert all the data into dictionary format called data dictionary. Then we insert all the values into our collection. So let's run this. So our result says, okay, I inserted everything in there, and then let's refresh. And as you can see, we have the test DB and the sentiment data collection and all the data in here. Thank you so much. Now, Monika is gonna present you our findings in image recognition analysis. Thank you so much.
Thank you, Attilla. Now I'm going to demonstrate image classification process. We tried to build the image classifier to predict our movie images. This is our code. Now I'm going to show it directly. We wrote the code for the image classifier. We built the model and then trained it. So this is my index page, and this is for the training of the training the model. Now I'm going to run this. We give some random images. It should predict which this was the image we selected. So now it is able to show the exact image. It is able to predict. That's how it is giving the exact image I sent. Let's try with one more image. This is the movie we gave. So it is able to predict this as Jurassic Park. That means it is able to predict the exact movie. We create a new project for the movies and then give the resource If we don't have, we create a new. I already have one, so I gave the resource name and selected the required classification and then classification type and created a new project. So now we are going to our project. I entered the tags action, comedy, crime, drama. We can add as many, like we selected 4 tags because those are the major tags, we major genres we are looking for. And then we add images to each tag. We select images and then enter tags action, comedy. If those by looking at our data, we add these tags and then upload the files. Then we train the model by quick training. I got the precision as 70% and recall 50%, and then I do quick test. Let's say, yeah. So for Godfather, I got this as crime, drama. Crime has 94.9%, drama is 8.6%. These are the only available genres we provided. So based on that, it gave what it has. So this is the process for these are the images for the process ID and provided the details. Here, Avengers has 90% and then 90% action. It is able to predict. It has a comedy as 10%, 10.8%. Drama as 7.5%. Crime 3.7. So these are the movies. I collected all the prediction rates and entered the details in Excel. So for our analysis, these are the movie names and the actual genres, and these are our predictions.
Thank you, Monika. The visualization part is simple. I expanded on what we already done with Power BI before, adding a new page and more features to it. Imported into all the sources we aggregated up until this point, including sentiment analysis, reviews, images, and channel predictions, and modified it so that it can respond to the data types Power BI uses. As a result, I ended up having 3 pages with some commonality between them. Let us explore. First page includes a list of the movies with data about every movie, a header, a filter section, and the word cloud representing the usage of different words in reviews. The first 2 pages both have the mini header consisting of 2 visualizations, Acar with information on the current section, and the sentiment distribution according to the filters the user set. Another feature present in both pages is the filter section. All filters in this section are synchronized between the 2 pages, allowing the user to keep their settings while switching between the views. Those filters include the movie genre, its rating, length, review polarization, and the year at which it came out. All sections also have a button to reset the filters quickly. Here is me using those filters. Let's say I only want to have shorter movies, high rating, and here we have 4 movies with 24 reviews total. It's Call Me By Your Name, Guardians of the Galaxy, Bohemian Rhapsody, and Little. And we can see how the word cloud changed that as well. Clicking on the word cloud, we can also set the filters by filtering out the movies that don't have in the reviews the word that is used in the cloud. It takes a little bit of time, but right now it should give us... And here we have it, 43 movies. And we can clear the filters now. The word cloud feature can be used both as a filter and as a display. Its composition changes between when user clicks on any movies in the list or any filters in the filter section. When the user clicks on any of the words, the word cloud adds its conditions to the previously set filters. The second page has the same filter and header elements, however the header is expanded to include genre distribution and review distribution. And instead of the list and the word cloud, we have a scatter chart on different movie genres, distributed over time and rating. Genre distribution and review distribution show the corresponding information about each of the group of the movies chosen by the filters, or specific movies chosen from the scatter chart, or polarizing movies distributed over time and rating. See right here. As with the word cloud, this scatter chart also acts both as a filter and as a display. Clicking on it allows users to get information about specific movies and genres. The third page does exactly that. It focuses on specific movies, allowing users to choose them from the list and see the specific information about them. Rating, number of votes, release year, and length. It also presents a little gimmick, showing the poster image and the results of the image recognition model that tried to predict the movie genre. Thank you, and take care.